In the circuit shown in the figure, the input voltage is 20 volts, the base emitter voltage is 0, and the collector emitter voltage is 0. The values of the base current IB, the collector current IC, and the current amplification beta are given by. Here it's given a common emitter configuration NPN transistor. So it is, first we have to identify the configuration and the nature of the transistor being used. So it's a common emitter configuration and an NPN transistor. And next it is asked to calculate the base current IB, the collector current IC, and the current amplification beta, which is given by IC divided by IB. And now to find out IB, let's use Kirchhoff's law in the base emitter path. So in the base emitter path, first case this is, so in the base emitter path, using Kirchhoff's law, VI, the input voltage, minus IB into RB, base current, minus VBE, the base emitter voltage, is equal to, we are reaching to the earth ground, 0. Therefore, VI is given as 20 volts minus IB we have to calculate, and the resistance is 500 kilo ohms, 500 into 10 power 3 minus the base emitter voltage is given as 0 is equal to 0, and therefore out of it IB value can be calculated. Therefore IB is equal to 20 divided by 500 into 10 power 3, and this is equal to 40 into 10 power minus 6, 40 microamperes. 40 into 10 power minus 6 it comes out, and this is in the base emitter path. Similarly in the collector emitter path, so in the collector emitter path, in the collector emitter path, again using Kirchhoff's law, using Kirchhoff's voltage law, Kirchhoff's law. Here 20 volts, this is actually VC, input voltage, and here VC minus IC, the collector current, into RC minus VCE, collector emitter voltage, again is equal to 0, and therefore this is 20 minus the collector current has to be calculated. RC is given 4 kilo ohms, 4 into 10 power 3 minus 0 is equal to 0. Therefore IC is equal to 20 divided by 4 into 10 power 3, and this is equal to 5 milliamperes. And now thirdly it is asked for beta value also, and next is beta. Also beta is equal to the current amplification, IC divided by IB. For small changes we use delta IC by delta IB. Here finite values we have IC by IB, that is 5 into 10 power minus 3 divided by 40 into 10 power minus 6, and this is equal to 125. So the base current is 40 microamperes, collector current is 5 milliamperes, and beta is equal to 125. And option 4 is our correct answer.